Okay, so in this video we have a pulley, and let's assume we have some masses. Let's have this one as 15 kilogram here for this mass, and here is 12 kilogram, and we are asked to get the acceleration with which the masses move when released from rest. And of course, we are also asked to find the tension in the string. And we are assuming in this case that this string is an inextensible string and that the pulley is a frictionless and a massless pulley. So the tension will be on this part here and on this part here. And the value of the tension here and here will be the same since the pulley is a frictionless pulley. So, but let's look at this tension here is the internal force in the system, but let's look at an external force in the system. That external force will be the force of gravity on these two masses, and it's going to act vertically downwards. So force of gravity will be pulling this mass down, and again will be pulling this other mass down. And what's the value of that force? The value is mg. That's how you get the value of the force of gravity on these objects. And of course, we know that the force of gravity on these masses is also equal to the weight of the masses. So using this formula, let's get the particular force that is pulling this mass down this way and also pulling this other mass down this way. So I'm going to use m sub 1g, m1g, and this one I'll use m2g for this other part. So let's now get the value of the force pulling this object down. So my m1 is 15, that'll be 15 times my g. We're asked to use 10 meters per second square for our g, which is the acceleration due to gravity. So that'll be 10. So that'll be 150 Newton. So 15 times 10 is 150. Then for this one, my m2 is 12. Then that 12 times my g, which is still 10. 12 times 10 will be 120 Newton. So definitely we know that 150 Newton is pulling this way. Let me write it up here. 150 Newton, and here is 120 Newton. So we now know that 150 Newton is pulling this mass this way, and 120 is pulling this way. Definitely we know that the acceleration is going to be this way, because 150 Newton is going to win this war between itself and the 120 Newton. 150 Newton is clearly bigger than 120, so it's going to fall. The masses will fall this way, and that means the acceleration is going to go this way. So, but to get the acceleration now, since they are falling this way, we are going to use the formula F equals ma from Newton's second law of motion. But the F here will be the effective or the resultant force. The M here will be their combined masses, the 15 plus the 12, and the acceleration is what we are looking for. So let me make the acceleration the subject of this formula by dividing both sides by m. So this cancels this. My acceleration is therefore the effective force over the mass. But what is the effective force here? Because I know that 150 Newton is more powerful than 120 Newton. So the acceleration or the masses will have to fall this way. But how do we get the effective force to fix here now? We are going to subtract, because we know that 150 is going to be leading 120 by 30 Newton if we subtract. So we are going to do 150 Newton minus 120 will get 30. So 30 is actually the winning force. It's actually the effective force, the edge that 150 Newton is having over 120. So I want to fix that 30 here. So the acceleration will now be equal to 30 over the combined masses, which is the 15 kilogram plus the 12 kilogram. 15 plus 12. The acceleration will now therefore be 37 over 27. We can still reduce this. 3 can go. We have 3 here, 10, and 3 here is 9. So we have acceleration is therefore equal to 10 over 9 meters per second square. So when the masses fall this way, this will be their acceleration from rest. Now, back to the tension. We are going to now focus our attention on this part of this pulley or this part. And of course, you know that from the beginning I told you that the tension is the same on this part and on this part, but we know that it is falling this way. So I can use this part of the pulley to get my tension by redrawing. Let me just picture this one out again on this side of my paper. So this is my mass. Let me use this part. So drawing out my mass again. So this is my mass. This is 15 kg. And I have the tension here holding it. And don't forget the work of the tension here. The tension here is trying to restrain this mass from falling. Even this one here also. So that's the work of it. It's a force that is trying to restrain the mass from falling. But of course, we know that the mass is still going to fall this way. So this force of gravity, which is 150 Newton, is actually greater than the tension. So let me draw that one out here. So the tension is here. This is the tension. And the force of gravity, which is 150 Newton, is pulling, and the tension, okay, let me change this arrow to this way. The tension is pulling up and the force of gravity is trying to pull down. But of course, we know that the force of gravity, which is 150 Newton, won the battle. So the masses eventually still fell this way. So we are still going to use F equals MA in this case to get the tension. F equals MA, and again at this point the force here will be the resultant force, the effective force. So the effective force, since the 150 Newton is greater than the tension we are looking for, the force here, because we are looking at either fixing 150 Newton here or the tension here, but we have to use the resultant of the both of them, which is 150 minus the tension, since 150 is greater. How do we know it's greater? Because 150 actually succeeded in pulling the masses down while the tension was trying to restrain it from falling. Of course, if the tension was trying to restrain it from falling and the 150 still ended up pulling it down, it means the 150 is surely, the 150 Newton is surely greater than the tension here, which is also a force. So for our force here, we are replacing it with what? With 150 minus the tension. Then we are still going to write equals MA. And don't forget that this MA is the mass, which is 15 kilogram. This M here, rather, is the mass, 15 kilogram. And the A is the acceleration we just found, which is 10/9. So we can now just fix the values and get our T. But you can also use this part of the pulley to also get your tension. But in this part, when the masses all go this way, the tension will be leading the battle on the right hand side of this pulley, because the masses will go this way, the tension is trying to pull, and it ended up pulling this way because of the help of this 150 Newton here. It pulled this way, and the mg here did not win the battle here. So in this case, if you have to use this right hand side of the pulley to get your tension, it would be, you will just do tension minus the 120 Newton at that particular part of the pulley equals MA if you were to use that part. So any which way you want, you still end up getting the tension if you use that one. But I'm using the left hand side, it doesn't change anything. So I now have 150 minus tension equals to, what's the mass? 15 times the acceleration, which is 10. I got 10/9. So I now have 150 minus T equals 150/9. I can still reduce this. I think 3 can divide. 3 here, 5, 0, 3 here, 3. I have 50/3. So I have 150 Newton. 150 minus T equals 50/3. And then I can multiply through by 3. Multiplying through by 3, I'll end up having, if I multiply through by 3 to eliminate this denominator, multiply through by 3, I have 150 times 3, that's 450, minus 3t, that's 3 times t, 3t equals, 3 cancels 3 equals 50. Then I'll collect like terms, and I have 450, I have minus 3t left on the left hand side equals this 50, this plus 450 becomes minus 450 here on the right hand side, and I have minus 3t equals minus 400. Then divide both sides by minus 3, so minus 3 cancels minus 3, and minus cancels the minus here, and I have t equals to 400/3 Newton. That will be the tension on the strings, both on the left hand side and on the right hand side, since they are the same, because the pulley is a massless and a frictionless pulley. So that's it for this question.